Hello PLP Geometry and welcome to the third video in Unit 3. So again, we are talking about these triangles and more ideas with triangles in Unit 3. So again, more with triangles. And this video, number 3, is titled Perpendicular Bisectors. Perpendicular bisectors, and then we'll put in or slash, we'll call this thing the circumcenter. Circumcenter. Sorry for being off center, right? So this is about the perpendicular bisectors and the circumcenter. Okay, so let's start with what's called the perpendicular bisector theorem. Now you have heard of a perpendicular bisector. I'm hoping that when I say perpendicular, you think of something, and when you hear bisector, you think of something. So we're going to put them together in the perpendicular bisector theorem. Okay, so what this theorem says is any point on a, and I'm going to use shorthand here, on a perpendicular bisector. So if you need to put the word perpendicular instead of upside down T, go for it, but I'm going to do the perpendicular bisector of a segment is equidistant. Equidistant. And again, that just means equal distance. It's equidistant from the endpoints, of the segment. Okay, so let's try to draw this picture. Let's start with the segment. So let's start with the segment XY. So I'm drawing it horizontal just to kind of help my picture. So there's XY. So again, if this is a bisector, it's going to go through the midpoint of this segment. So I'm going to put a point right in the middle called M for midpoint. Now again, to show that, I'm going to mark these two segments congruent because a bisector splits a segment into two congruent segments. And then I'm going to draw a line going vertically through point M. And again, this is because my segment was horizontal. Again, try to go through M, unlike me. So now when I draw this line, right, I have a right angle there because they are perpendicular, the line in the segment. So now if I put a point P somewhere up here, it could be anywhere on this line, right? If I connect P to X, and if I connect P to Y, because P is on the perpendicular bisector of the segment, the length or distance from P to X should be equal to the length or distance from P to Y. So P, that point on the perpendicular bisector, to X, one of the endpoints, is equal to the distance from P to the other endpoint Y. Okay, so this is helpful because we're going to use this idea to locate what's called the circumcenter of a triangle. Okay, so let's talk about this circumcenter. Okay, so a circumcenter is called the point of concurrency. So point of concurrency. And this point of concurrency is just a fancy word for the point of intersection of the perpendicular bisectors of a triangle. Okay, so let's try to draw this circumcenter, and then we're going to draw what's called the circumscribed circle. Okay, so let's start with a triangle, and again, I'm going to make it acute looking. So it's going to be like this. Almost looks equilateral. If it's not equilateral, that's best. But again, we can just make it equilateral to kind of save ourselves. Okay? So there's my triangle, right? If you want to call it A, B, C. Okay, so what we need to do is we need to draw or construct two perpendicular bisectors to two of the sides, right? There are three sides, so there are technically three perpendicular bisectors in this triangle, but we only need to do two, okay? So to do this, I'm going to mark the midpoint of one of the sides. Let's mark the midpoint of AC. Okay, that is a midpoint, which means that this segment is congruent to this segment. And now let's draw a perpendicular going through there. Now, this perpendicular can go as long as you want to, all right? So I'm going to just draw it from here straight down. This is my perpendicular. Okay, so there is one of my perpendicular bisectors. I'm going to do the same thing with BC. Let me change colors again. I'll use yellow. So if this is the midpoint of BC, and now I just need to draw my perpendicular bisector long enough so that it intersects the first one. So this way. And boom. And again, these two segments are congruent, and that makes a right angle. And there is my second perpendicular bisector. And what I've done is I've created a point of intersection right here. That point right there, let's call it point P. That point P is called the circumcenter. So P is the circumcenter. Center. Okay, so now, based off of the perpendicular bisector theorem, since P is on the perpendicular bisector of segment AC, the distance from P to A is the same as the distance from P to C. So P to A equals P to C. Well, since P is on the perpendicular bisector of BC, it's also equidistant from C and B. So P to C equals the distance from P to A, or sorry, P to B. So P to C is equal to the distance from P to B. And because PA and PB are both equal to PC, that means PA is equal to PB. That's the transitive property. And all of these distances are the same. These distances are going to be the radii, that's the multiple word or the plural name for radius. Those are the radii of what's called the circumscribed circle. Circumscribed circle. That's a circle down there. Sorry. Let me make it a little bit better. For all those who know my handwriting struggles at times, I'll try to make it better. Circumscribed circle. Okay. So now what I want us to do is I want us to do our best to draw a circle, right, going through points A, B, and C. Because if those three segments are radii, P to A, P to B, P to C, then this circle goes through those 3 points. So I'll do my best right here. So I'll go like this, and then boom. Look at that circle. That's a beauty. And this is what the circumcenter can create. It can create what's called the circumscribed circle about the triangle. But this point P is the same distance away from the 3 points A, B, and C. Okay? All right, so what we're going to do here is we're going to talk about how you construct this circumscribed circle. Then we're going to do it in Desmos Geometry, different type of software. Okay? So if you take a look at this picture, I'm going to write the steps down below. I'm going to write on the next slide, but you just write it down below. And again, it goes with this picture. All right? So if we take a look at constructing a circumscribed circle, construct a circumscribed circle. So I'm not going to draw the pictures because I drew that one up there. All right. So when you're doing this, the first thing you're given is a triangle. So you'll be given a triangle. So, step 1. You are going to construct 2 perpendicular bisectors. So, construct. Construct, if I could spell. Construct. Construct perpendicular bisectors of 2 sides. When you do that, they're going to intersect. Mark the circumcenter. And again, the circumcenter is the intersection point of those 2. INT points. Once you have the circumcenter marked, you are then going to take a compass, right? And you're going to use a compass. Use a compass to draw a circle. With center at the circumcenter, passing through all 3 vertices of the triangle. So we start with the triangle. We're going to make 2 perpendicular bisectors. And again, we're going to use Desmos geometry to cheat and do it for us. Once we find those 2 perpendicular bisectors, we're going to mark the circumcenter, and then we're going to make a circle using a compass. The center of our compass will be on the circumcenter, and then we'll just use the other 3 points to draw through. And you'll get it. Alright, so let's take a look at this in real life. Again, you're going to have to do this, so please make sure you pay attention. Alright? Okay, so this is called Desmos geometry. I know it's your first time seeing it. No big deal. Alright? So, here's my sketchpad tools. Notice I clicked on the double arrows to make that go away because I don't need that. Alright, so the first thing is, we're going to use this polygon tool to make a triangle. So here's how you do it, right? So you're going to click on that polygon tool. Again, you can make 3 points anywhere. 1, 2, 3, and then finish it off by reconnecting to the first point. All right. So now we need to make 2 perpendicular bisectors. So the first thing I need to do is mark 2 midpoints. So if I click on this down arrow, see the word midpoint. If I just click on where I think 2 midpoints are, it gets put right where it goes. Same thing, I'll do it down here. See, I can even move off that and it even puts it right in the middle. Boom. There's my 2 midpoints. Now, I need to draw 2 perpendiculars through those midpoints. So if I come to this segment and I click the down arrow, see it says perpendicular. Now when you do this, you first have to select the segment you want to be perpendicular to. I would like to be perpendicular to this side of my triangle. Let's do the bottom one first, this side. Now you select the point you want to go through. I want to go through its midpoint. Boom. There's the first perpendicular. I'll do the same thing with the other side that I made the midpoint. I'll mark it, and then I'll put my point through the midpoint. Notice that I have this point of intersection. I'm going to click on this point tool, click on point, and I'm going to mark that point. Notice that both lines highlight. That's because it intersects both lines. And there we go. There's my circumcenter right there. Boom. Okay? So now what I want to do is I want to grab the circle tool. You're going to click on that circumcenter and drag it to one of the 3 corners of the triangle. I'll do the bottom right. Oh, sorry, hold on. My bad. So we're going to click. We're not going to drag. So we're going to click on the center, and then we'll click on one of the vertices. And there is the circumscribed circle. Now notice that I can move the triangle. Right? Notice that the perpendicular bisectors move with it, but notice that the circle stays through all 3 vertices. This is very important. Now I do want to show you a couple of things, right? So this is an acute triangle. Notice that your circumcenter is in the inside. Notice what happens when I try to make a right triangle. So that's about a right triangle. Look at where the circumcenter is. It's on this side of the right triangle. That's called the hypotenuse. Now look what happens when I make it an obtuse triangle. Notice now the circumcenter is outside of the circle. So this is true. This is true depending on what type of triangle it is. Acute triangles, the circumcenter is on the inside. Right triangle, it's on the hypotenuse. And outside, an obtuse angle, it's on the outside. So what you're going to do now is there's a delta math, a very quick delta math, and then you're going to do this project, okay, on a map of Twinsburg. So you're going to, and I'm going to have an example of it, but I just want to explain it real fast. So you're going to use these transparency pieces of paper to mark 3 spots on top of the map. So you're not gonna draw on the map. You're going to mark it on the transparency on top of the map. And then what you're going to do is you're going to find the circumcenter for those 3 locations in Twinsburg. Think of this as a meeting spot. So suppose you and 2 other friends are all at 3 different locations. So for example, say one of you is at Handel's, one's at the high school, and one's at the library. And the question is, where would be the place that we could all meet so we walk the same distance? That is our goal to find, okay? So I will have an example for you, and again, you can ask me questions as you're trying to attempt it. But this is our Unit 3, Number 3 activity, okay? All right, so hope you have fun doing it.